All right, so let's get started. So today we're going to talk about empirical work on externalities. But before I start that, I just want to make a quick correction to something I said in the last lecture, which was a mistake, which is in the Weitzman paper, it's not just the slope of the marginal benefit curve that matters for whether you want to choose prices versus quantities. It's also the slope of the marginal cost curve matters as well, as Martin pointed out to me at the end of the lecture. So it's the ratio of the slopes of the marginal benefit curve and the marginal cost curve. So what we discussed is that when the marginal benefit curve is steep, you want to use quantity methods instead of price methods. So that's still correct, holding fixed the slope of the marginal cost curve. But if you're also varying the slope of the marginal cost curve, then it's the ratio of the two that ends up mattering. And you can see that if you go back to those graphs, you'll see why the relative size of the triangles depends upon the ratio of the two slopes. Okay, so today we're going to talk about how we actually measure the size of the externalities, which is crucial, whatever method you're going to use, whether a price method or a quantity method, in determining the size of the tax that you want to levy or the amount of quantity regulation that you want to do. So there are two approaches that we will discuss. I'll spend most of the time on what are called indirect market-based methods. And then I'll talk a little bit about contingent valuation, which is the other main method that's used, but I think is actually quite problematic. So we'll talk about a bunch of different examples. There are obviously lots and lots of examples of people trying to measure externalities. So I'll try to illustrate a few different methodological approaches. So the first paper I'm going to talk about is by Edlin and Karaca-Mandic in 2006 in the JPE. And what they're interested in are the externalities from driving. So basically the idea that if I drive, I increase the probability that you will get into an accident if you think that people, so empirically people get into accidents with other cars, not like running into a tree or something. And so I'm imposing an externality cost on everyone else when I start to drive, right? So what they want to do is estimate the size of that externality and the appropriate Pigouvian tax to correct for the fact that when I get on the road, I'm not taking into account the cost that I'm imposing on everyone else in expectation. So the way they get at that is clever. They examine the relationship between traffic density and per capita insurance costs and premia. So the idea is that the insurance company in any market is going to break even, right? They're going to set average prices so that they don't lose money. And so by looking at insurer costs and how much insurers are charging people, you can get a sense of the total cost of everyone being on the road. And if you think about how you'd want to set this up, ideally, like if you were running a randomized experiment, you'd want to have one place with a higher density of cars and another place with a lower density, and you'd say, how different are the insurer's costs in these two settings? And then we'd get an idea of how much more damage occurs as the density rises. So the way they implement that empirically is they basically look at the slope of the relationship between traffic density and per capita insurance costs, just examining geographical variation across cities in density. Okay, or really they look, I think, basically mainly at the state level, where they look at variation in traffic density, and they try to isolate the part of it that's not correlated with other determinants of insurance premium, right? So that's the key problem that they have. If you compare insurance costs in California with Arizona, part of it could be because there's a different density in the two states, which is what they're interested in. But it could also be that people drive luxury cars in one market and not the other, and that's going to contaminate things, okay? So that's the usual omitted variables type of problem, and you can think about how you try to handle that. So let's just look at the basic cross-sectional pattern, which conveys the idea. So this is a plot of insurer costs, so a dollar charge per vehicle mile traveled, okay? And on the x-axis is traffic density. Measure of traffic density, the number of vehicle miles traveled per miles of road that you have. And you can see, first of all, as you'd expect, that insurance costs are higher in places with more cars on the road. Okay, so think of like LA or something on the right side, or New York City, and then more rural places on the left side. So that's insurer costs. Now you can replicate the exact same thing with insurance premiums. Okay, so what people are paying the insurance company. And these two things look similar as you'd expect, because otherwise the insurance companies would not be meeting the zero profit condition, basically. So what this is telling you is in competitive equilibrium, as you'd expect, in the places with higher costs, there are also higher insurance premium, right? And so the key problem then arises from the fact that insurance companies are setting premia to meet average costs rather than marginal costs. And that's why the externality is not being priced. Okay, so what are they showing here? Traffic density substantially increases marginal insurer costs. So let's interpret that relationship as causal. Obviously, there could be other confounds. That's not what I'm focusing on here. So the problem is that insurance companies set premia to cover average costs in market equilibrium, as they have to. That's what the market's going to force you toward, as we've talked about in the social insurance lectures. But the problem is that with average cost pricing, the individual's marginal cost on other drivers is not internalized. So come back to this picture here, and suppose I buy a car and get on the road, thereby moving us down the right side of this curve. I get charged the average premium now that everybody has to pay, but everyone has to pay like an extra dollar or something, or an extra dime, because my car is now on the road, which is increasing the expected probabilities of an accident for everyone, right? What you can furthermore see from those graphs is that the externality cost looks like it's going to be convex, right, which is intuitive. So if you increase, they estimate that an increase in traffic density starting from the mean has an external cost of $2,000 per year in California. The comparable figure in North Dakota is only $10 per year, because there just aren't that many people on the road, right? So it doesn't matter if one more person gets on the road. And so their bottom line conclusion is that you want to double insurance premiums in California in order to achieve the social optimum. You basically have too many people on the road relative to what's efficient, given the way insurance. But just to illustrate the approach, let's say you make that strong assumption. So essentially, what are you going to do? You run a regression that looks like this: price of the house on the left-hand side on a measure of local pollution with various controls, right? So what are the econometric problems that arise in this setting? So there should, by the way, be a coefficient there, obviously. So first of all, you have the usual emitted variables concern, that the places with more pollution are not going to be comparable to the places with less pollution. And that's a serious problem typically, because where do you have more pollution? It's like more industrial neighborhoods, which you don't want to live in anyway, et cetera, et cetera. Okay, so that's familiar to us from many other settings. There's a deeper problem here, which actually is much more fundamental, which is sorting. So let's suppose you have the ideal case where you do in fact randomize pollution across neighborhoods. Now suppose you have heterogeneity across people in terms of their sensitivity to pollution. Okay, so suppose some guys, like to make this concrete, don't care at all. They're just insensitive to the pollutant. And other guys have allergies and really do not like the pollution. So from what we're trying to price, or what we're trying to figure out, is what is the average willingness to pay to avoid pollution in the population. So if we're trying to set some policy to reduce emissions and set the optimal tax, the corrective tax that we want to impose relates to the average cost that we impose on people in the economy. But here, you can end up with a situation where the prices actually are not any different across the polluted and non-polluted areas if you have a sufficiently large number of people who are insensitive to pollution and are willing to live in houses where pollution levels are high, right? So suppose, for example, I have a small number of neighborhoods with high levels of pollution, and I have like 20% of the population that doesn't care at all about pollution. So those 20% of people are going to sort into the neighborhoods where pollution levels are high, because they don't care. And the other 80% of guys live in neighborhoods where pollution levels are low. And because prices are set by the marginal buyer, you're going to find that the equilibrium price is going to be the same across the two places, even though 80% of the people might be willing to pay quite a bit to avoid pollution. So you're going to get it totally wrong because you estimate the marginal willingness to pay rather than the average willingness to pay. That is a much more serious problem because even when you set up the ideal experiment, you can't, you suffer from that. Okay, so I'm not going to talk about the empirical results of Brookshire because they are, biased even by the omitted variables problem. So a more recent paper that uses a quasi-experimental approach that at least deals with the omitted variables, I think, pretty effectively, but may not quite deal with the sorting, at least you have to think about whether it does, is Chay and Greenstone. So this is representative of a number of papers by Michael Greenstone and others in this literature that apply this type of methodology to measure the costs of various externalities. So they also study home prices, but they are going to use an exogenous change in pollution created by the Clean Air Act, which imposed ceilings on pollution levels by county in the US in the mid-1970s. So they basically put a cap on the level of particulates that you could have that was uniform across counties, okay? And what that type of uniform cap does, it's actually a very useful research design because you have heterogeneity in where people are relative to that cap ex ante before it was implemented, and that generates differential treatment effects across areas, all right? So in particular, if you're a high pollution county, you're now going to be forced by the government to bring down your level of pollution quickly. But if you were below the cap to begin with, you're not treated. So that's actually a very useful design in many contexts because you often get these uniform caps that are imposed. And so here's the first stage graph. So they distinguish between non-attainment counties, which are places before 71 they were, or before this law was implemented, they were above the threshold. The threshold is shown here by this solid line, and you had to come below that within a couple of years after the law was passed. The attainment counties were already below that threshold, so they didn't have to do anything, or at least they weren't forced to. So as you would expect, the gap between these two types of counties closes rapidly after the law is implemented. And so now you have basically a diff and diff setup, right? You can compare house prices in these places relative to these places and see how they evolve. And so that's what they do here. So in this table, they are showing you various specifications as they add more and more controls for the first stage. So this is replicating exactly what we saw in the graph, the mean changes in total suspended particulates in the non-attainment counties relative to the attainment county. So it's standard diff and diff regression like we've seen many times. And you see a significant first stage reduction in the non-attainment relative to attainment. And then the second panel is the reduced form. So percentage change in house prices in those areas. So what are we seeing here? Like in this specification on the left, you see about a 3.6% increase in house prices in the non-attainment areas relative to the attainment areas, suggesting that people are willing to pay more to live in those places. Now, one thing I'll point out is, you see a relatively large and significant effect here, and it looks like as you add controls, the effect still seems to be there. But one thing you should be careful about, or be a little bit concerned about, is that the coefficient is basically falling steadily as you go to the right. So it falls by 50% by the time you've added a bunch of controls. And so then that kind of thing always makes me worried that who knows what other controls we haven't added, and whether the effect is actually going to remain. But in any case, it looks like there is some reasonably credible evidence here that house prices go up when pollution levels fall. Yeah. So the Roback model is also about sorting, basically. So what I was going to say next is that you're exactly right. Because of the firm sorting channel, or even just individual sorting, the point that I was making before, if you sort dynamically, which is plausible, I mean, you have to move to buy a new house after all, right? Then again, these coefficients could be biased because the marginal guy who's moving in might be a guy who does or does not care about pollution in a way that's different from the average, right? So I should be careful when we say biased. I mean biased as a measure of average willingness to pay, right? Now, if you define the parameter you're trying to estimate as the marginal willingness to pay, taking into account all the changes in wage rates, firms, et cetera, then you've measured that treatment effect. The question is, can you map that treatment effect to the type of parameter we were interested in for the basic, like, Pigouvian tax calculations, and that's much less clear. So what did Chay and Greenstone conclude? A 1%, so I showed you the reduced form in the first stage, you put those together. 1% increase in pollution leads to about a 0.25% decline in house values, implying that the Clean Air Act increased house values by 45 billion in treated counties, a substantial treatment effect. In addition to the various concerns we've raised, I think the point Ji-Sung had made about short-run market-based methods, people may not be fully aware of the changes in pollution or their consequences, et cetera. I think that's something that's interesting to explore. So you could imagine, for instance, a treatment where rather than having people move around, you give them information about pollution or somehow make the pollution levels more salient and see if that affects willingness to pay, see if that affects behavior. I think that would be interesting. Okay, so there are lots of applications like that. Now I'm going to go in a different direction, show you a different type of application, which focuses more on quantity regulation and thinks about what that does to allocation. So it's not really about externalities per se, but it illustrates issues that arise in externalities when you're trying to treat externalities, in particular when you don't use a cap and trade policy, okay? Shows you the importance of cap and trade. It's a very nice paper by Glaeser and Luttmer in the AER in 2003. So the main point they make in this paper is that without tradable permits, the efficiency costs of regulation could be very high because of allocation distortions, which we don't think about in the standard setup, as I'll show you. So they study in particular the allocation of apartments under rent control. And their point is the following. So the standard model assumes that with price controls, you still have allocative efficiency up to the point that's feasible, meaning when I impose a cap on rents, okay, we know that there's going to be an undersupply of quantity of apartments, or there's going to be an undersupply of quality. Basically, the market gets rationed in some way. And usually what we assume when we calculate the efficiency cost of that policy is that the people who value the apartments the most end up getting the apartments, okay? And that ends up making the allocation distort. So the apartments get allocated correctly, but you get an efficiency cost because you're not at the efficient quantity level, okay? That's what generates the efficiency cost in the standard model. But their point is that regulation will generally lead to an allocative inefficiency that generates first-order welfare losses. So in particular, you no longer have the right guys in the right apartments, because once you put in this restriction, this regulation, the standard allocation mechanism breaks down because you can't basically allocate apartments by price. And so how do you end up allocating them? There's queuing, essentially, right? So if you're lucky and you happen to know the landlord, or you find out about the apartment very quickly, you might end up getting a 4-bedroom apartment when you really only would have paid for a 2-bedroom apartment just because you happen to be in the right place at the right time, right? So the wrong people get the wrong apartments. And what they show is that for small price caps, the allocation efficiency dwarfs the undersupply inefficiency because it's first order, whereas the quantity inefficiency is second order. It's going to be the triangle. All right, so let's see how that works graphically. All right, so standard supply and demand partial equilibrium setup where you've got a supply of rental housing shown by this curve, and then demand for rental housing here. And let's think about consumer and producer surplus. So forget about income effects, just Marshallian notions of surplus. So in the free market, the market clearing price would be here, and we'd be at point B, right? Where this would be consumer surplus, this would be producer surplus, and surplus would be maximized. Now we impose rent control, let's say for distributional reasons. And so we're focusing here on efficiency, what happens to total surplus as a result of that policy. So the rent controlled price, let's say, is down here at C. And so the quantity now is going to be restricted by the supply side. Landlords are not going to want to supply more apartments. They're not going to want to rent them out. They'd rather sell them or live in them themselves. And so you're going to see this gap in willingness to pay for the marginal apartment relative to the cost of putting it on the market. And so in the standard model, that destroys surplus that's proportional to this triangle here, where the consumers lose this much surplus and the producers lose that triangle. That's the standard deadweight loss triangle that we saw early on, right? Okay, but their point is the efficiency cost is actually much bigger than that, because in this simple model, we are still assuming that the guys who get the apartments are these people up here who are willing to pay the most for these apartments. But as I was saying, there's no reason to assume that that's going to be the allocation mechanism once you have this restriction. In fact, you know, if I'm down here just barely willing to pay more than the market price, then I get a lot of surplus from getting this rent-controlled apartment. I'm very happy to get it. So I'm still going to show up in the queue, and there's no way for basically the guy who's up here willing to pay quite a bit more, who comes right after me to say, no, look, you know, I'm actually willing to pay a lot more for this apartment. Let me have it instead of you. That mechanism of transfers breaks down, okay? And so a bunch of the people who are buying the apartments are down here rather than up here, and you're basically getting rid of a bunch of very high surplus people. And so the resulting diagram, which is more complicated from their paper, that takes all these effects into account, is this, where you have lost consumer and producer surplus due to undersupply. That's the term that we had before. But then you have this additional lost surplus, which comes from the fact that the average valuation of the people who are getting the units is not the average in this range. It's the average over the entire demand curve above the point, above the equilibrium price. Not just, I should be clear, not just above the equilibrium price. It's actually even the guys down here who would not even be willing to pay the market price. They're going to show up and want to get the rent-controlled apartments, right? And so you end up losing quite a bit of consumer surplus due to misallocation. And that term is going to be first-order proportional to the size of the price cap, unlike the quantity loss thing, okay? So what they do in the empirical part of the paper is quantify the welfare losses from misallocation by comparing consumption patterns in rent-controlled apartments in New York City to free marketplaces across demographic groups. Okay, so the logic is basically the following. You predict the optimal apartment size, or the apartment size a person would have chosen in an unconstrained environment using some demographic variables, like the number of people in your family, income, education, age, and so forth. Take a bunch of cities, they take 105 large MSAs, and fit this model, which is what are the apartments people are choosing given their demographic characteristics. And then basically assume selection on observables. So there are no unobservables that are driving choice that matter for the analysis. And then test if the actual apartment allocations in New York City match the predictions. So in other words, do we see an excess number of people with, let's say, only one kid living in a 4-bedroom apartment, and do we see too many people with 3 kids living in a 2-bedroom apartment and so forth relative to other cities, right? So what's the identifying assumption here? Preferences have to be stable across the MSAs, right? So for instance, Philadelphia has to be a good counterfactual for what people in New York would do if there was no rent control. And you can debate that assumption, of course. And one thing they do to try to evaluate that is implement their analysis. They do placebo tests in cities that do not have rent control. So basically repeat the thing with Chicago or with Hartford, Connecticut. And what you should see there is you should find very low efficiency costs, right? And they basically find that. So let's see what their data looks like in New York. So this matrix compares, it looks at the allocation of people across cells of efficient apartment size. So this is the apartment we think they should be in, given their demographic characteristics based on this model they fit, against the actual apartment that they're in. So if the apartments were perfectly allocated and the model was correct, all the mass would be on the diagonal. But in fact, their point is a substantial amount of the mass is not on the diagonal. So you do see more mass on the diagonal than off. So the apartments here are coded by number of rooms, right? So for instance, among 3-bedroom, or take for instance 2-bedroom apartments, you see 7.6% of the population in this cell where they should be in a 2-bedroom apartment, and they are in a 2-bedroom apartment. But you see nearly half that many in a 3-bedroom apartment, and a third as many in a 1-bedroom apartment, which suggests that a bunch of people, a good chunk of people, are being pushed off of the optimum because of the New York City price caps, right? So there's substantial inefficient allocation, basically, is their calculation, and then they can measure the size of this misallocation. So how does this connect back to the externality applications we've been talking about more generally? I think it illustrates the importance of cap and trade, right? So you can see that if you implemented a quantity regulation that basically required all firms to change their behavior in some way or something like that, you're going to get this type of allocation inefficiency. Or if you set up a restriction that essentially generates queuing rather than using price mechanisms for allocation, you're going to get this type of inefficiency. And the technique that they develop here could be used to quantify the importance of that allocation inefficiency. Oh, what's the hypothesis test that you could do? So there are various tests you could think about. So one way you could do it is a regression with dummy variables, and you do an F-test to see if the coefficients equal what you would expect. So here's another way. So suppose you just, let's say you take the guys who should be in 2-bedroom apartments, okay? And then just regress the probability, to make it very simple, that they're in a 1-bedroom apartment on, actually let's do it the other way. Regress the probability, that an indicator for whether you are actually in a 1-bedroom apartment on what the optimal apartment size for you is on indicators. And what we should see is there should be basically no chance that if the optimal apartment for you is a 3-bedroom apartment, that you're in a 1-bedroom apartment. And so you can see how the coefficient you get from that regression with indicator variables, you do a t-test on that. That's a test of whether any one of these coefficients is significant. If you want to jointly test the significance of all of them, you do an F-test in a regression with a bunch of dummy variables. That's essentially how you'd implement it. That's one way to implement it. I don't know exactly what they do here. Okay, so we've talked about basically a bunch of examples that use prices in some way, or actual data on choices in some way, to back out the size of these externalities and the inefficiencies we might create when correcting the externalities. So there's a totally different approach, which actually also is quite developed, but has fallen out of favor, I would say, which is called contingent valuation. So the idea here is that for some outcomes, it's really impossible to have a market value. Even these indirect sort of methods of using insurer costs or house prices or whatever, it's really hard to think how you would ever figure that out. So like protecting endangered species. People are probably willing to pay for that. There's interest in supporting that. The government spends money on that. How much should we spend? I mean, it's very hard to imagine that you'd somehow find some sort of price or quantity that's going to tell you the answer to that question. So what's a common solution? It's these contingent valuation surveys where you basically ask people, right? So how much would you be willing to pay to avoid the extinction of whales? And it's contingent valuation because you're trying to say, like, under various circumstances, if we were to do X or Y, what would you be willing to pay in various scenarios? Okay, so Diamond and Hausman have a paper in the JP in 1994 which summarizes this work and then provides, I think, a pretty strong critique of it. that at least I find compelling. So their main point is that the answers you get here are really not very reliable, okay? And I think fundamentally one reason for that is there's no resource cost to the respondents, right? So like if I come and ask you, how much are you willing to pay to save whales? Your main incentive there is that you don't want to come across as some guy who doesn't care about whales, so you tell me you want to spend a lot on saving whales, right? So that's one problem. And then you see a clear lack of consistency in responses, which they give you many examples of in the paper. So for instance, if I ask you how much you're willing to pay whales, and then I ask you about seals, you tell me more for whales than seals than if I flip those questions around, because you kind of have a diminishing willingness to pay to save animals. Or if I ask you how much you're willing to pay to clean one lake, or I come and ask you how much you're willing to pay to clean 5 lakes, you'll basically get the same number, because people just have some like rough sense that I'm willing to pay something for this, right? So, there's talk of how you can design better surveys and so forth, but basically their view is that you want to let experts decide based on a budget that's voted on by individuals for the environment in some broad way. So like maybe you can somehow elicit people's willingness to pay for a better environment and then leave it to a set of experts to determine this is the most efficient way to do that or something. Their basic view is contingent valuation doesn't really go very far. Okay, and so I'm not going to spend more time on that here, unless people have questions. Okay, so I think some of the most interesting work on externalities is actually being done in the behavioral economics context, where it's not really about externalities, but it's what people are calling internalities, where you are essentially having an externality on your future self, or doing something to yourself that ideally you wouldn't want to do in some sense. And so there's a literature which I want to talk about now that's emerging and has both theoretical and empirical work on the optimal ways to correct these internalities. So the simplest example would be sin taxes. So things like taxes on cigarettes or alcohol, which we might think are there to raise revenue, so that would be the Ramsey perspective. But there might also be a Pigouvian perspective, not just that smoking might have a, secondhand smoke might have a cost for other people, but that you might actually be hurting yourself, right? And in fact, if you look at studies in public health, the internal costs of smoking cigarettes dwarf the external costs. So it's hard to rationalize the very high taxes on cigarettes that we have in the US, either from a Ramsey perspective or from a strict Pigouvian perspective of I want people to smoke less because it's affecting other people, okay? So the question in this literature, in the context of cigarettes, is whether the addictive nature of cigarettes might motivate taxation, right? And the answer to that question is that it's highly sensitive to the positive model of addiction, unfortunately. Okay, so this is a case where the sufficient statistic kind of view that the model does not matter doesn't seem to work. And the challenge is that it's difficult to determine which model is actually correct empirically. Right, so let's talk about a few different models of why people might get addicted to cigarettes, and then see how their optimal policy prescriptions will be very different. Okay, so the first model is due to Becker and Murphy. It's basically a model of rational addiction. So what Becker and Murphy say is that the consumption of addictive goods can be modeled in a perfectly rational framework. So think about a dynamic model with habit formation. So what that means is utility is not just a function of CT as we usually write it, but it's also a function of CT minus 1. And often the way we might model this is it's U of CT minus some stock, some decay parameter, where we have a lambda CT minus 1 with some lambda less than 1, right? So like the amount of utility I get today is like how much I'm consuming relative to what I was doing yesterday. And if I was smoking a lot yesterday, then it's really costly for me not to smoke today. So you can see why this leads to like an addiction type of pattern. So in their model, current consumption of the addictive good decreases utility in future periods, as you can see here, right? So if I'm in period t minus 1, I have more utility today, but I'm going to reduce my utility tomorrow because I'm increasing my habit, increasing my stock. But it's going to increase the marginal utility of consumption tomorrow. So if I've been smoking a lot, my marginal utility of further consumption is very high, and so I want to continue to smoke, okay? So I have both of these features in the model, and then you can see that if the discount rate is high enough, so I don't care about the future that much when I'm making decisions when I'm, say, 20, then I can perfectly rationally choose to smoke and end up becoming addicted. But if I don't assume that my discount rates are incorrect, that is, the government just says this guy has a high discount rate, I'm going to maximize the present value of his utility given whatever his actual discount rate is, then you're totally in the rational model. You see people becoming addicted to cigarettes. They chose to make that decision because they have high discount rates. There's no reason for us to do anything about that, okay? It's a totally, you're back in the Ramsey model, basically. No reason for special tax rules, just set tax rates according to the Ramsey model. So now let's talk about problems with discounting. So that's a very natural thing to think about. So the paper here is Gruber and Koszegi 2004 QJE, where you can think of it as essentially Becker-Murphy, but with hyperbolic discounting for smokers. So hyperbolic discounting is one way to think about it in these applications is it's one way to parameterize why the government's view of what your discount rates should be are different from the decision maker's view of what he actually uses when making choices. So the idea of the beta delta model is the individual is applying this beta less than 1 to the future stream of consumption, but the government, for whatever reason, knows that I want to maximize the present value of utility, taking beta to be equal to 1. So essentially what that is saying, I think the guy is putting too little weight on the future when he's 20 than he should be, and I'm going to try to fix that, okay? So, you're all familiar with the basic setup of these quasi-hyperbolic preferences where it's like the exponential model, but you put a beta weight in front of the continuation utility, and you do that in every period, which is going to make the individual's decisions time inconsistent because in every period, he's going to want to change what he does, change his plan. All right, so in this model, the planner maximizes the initial utility, U0. There's an issue in all of these models of what utility the planner should actually be maximizing, but what they assume is planner maximizes U0 with beta equals 1. So what's going to happen here, it's very easy to see, the individual is going to overconsume C because essentially, think about the extreme case where I have beta of 0. I don't care about the future at all. I'm going to consume way too many cigarettes today relative to what I should be doing if I take my future health consequences into account, right? And so what Gruber and Koszegi is about is calibrating the optimal tax. So their policy, the policy instrument they consider are Pigouvian corrective taxes. And they say the corrective tax should actually be quite large, perhaps similar to or even larger than the taxes we currently have, given some calibrations of beta and delta. So that comes back to the question of how do you estimate beta and delta? And as I was talking about, there are a bunch of ways. You can try to elicit preferences, trade-offs. In this particular parameterization, the sharpest way to get at it is how much are you willing to trade off money today versus tomorrow, and then compare that with tomorrow versus the day after. And the first one is going to tell you beta times delta. The second one is just going to be delta. That's under this particular functional form. And then you could estimate both those parameters. They take some values from the literature, and they calibrate the model and argue that you should have really high cigarette taxes. Okay? Now, what's very, I think, interesting about this literature is that while it might seem totally intuitive that the way to fix this problem, if you're in the Gruber-Koszegi world, is to have a tax, it's actually not at all clear that the tax is what you want to do. And in fact, the tax might not do anything beneficial. So I'll illustrate this with the Bernheim and Rangel paper, 2004, which has a different positive model of addiction. So rather than the habit formation type of model that, going back to Becker-Murphy, they have a model of what they call Q-triggered addiction, where you have two selves. So you have a cognitive self with rational preferences, and then you have a visceral brain that's triggered by random cues in which the addictive good is consumed at any cost, okay? So rather than this model, which is kind of like, I'm putting too little weight on the future, it's like you flip between doing one of two things. So this is like a rational choice. You would do this, okay? And the way it's being modeled in Gruber-Koszegi is we are modifying this objective function by making this delta too low, essentially, in future periods. But what Bernheim and Rangel are saying is, like, most of the time you do this, 90% of the time you do this. But then sometimes you go into this other state where your utility function just becomes max, you're in period 0 and you just want to max over C0, U of C0. You're just like, I want to consume this thing as much as I can because I'm thinking about smoking, or I want to consume now. I'm not thinking about saving, whatever it is, right? And so, that also is going to generate this type of addictive behavior. So the idea of the addictive behavior is current consumption depends upon past consumption levels. How do you get that in this model? Well, the way they have it set up is the probability that you get triggered into this state where you just want to smoke is a function of how much you've been smoking in the past. So if you've never smoked, you maybe like when you see an ad for cigarettes, you don't really care. But if you've been a smoker or whatever else, there's certain triggers that might make you want to consume more. And so then that's going to generate that property that guys who've consumed a lot in the past will be more likely to consume now. Now, empirically, what I find interesting about this is empirically this is going to generate a data set that looks very similar to what this model generates, okay? But the ideal policy, the optimal policy, is totally different. So what you really want to do here is only allow people to consume in this state, the rational state, but do not let them consume or make them consume much less in the hot state where they're not thinking through things clearly, right? And interestingly, corrective taxes may be sort of exactly the wrong policy, because what corrective taxes do is get you to change your behavior in the rational state where you are actually thinking about prices, but not in the hot state where you're just saying, I don't care what the price of the cigarettes is, I don't care what the cost of alcohol is or whatever, and you just end up consuming. And so the corrective tax, contrary to the Gruber-Koszegi model, actually ends up reducing welfare because you distort behavior inefficiently in the rational mode, right? And you do not affect behavior in the hot mode, which you're actually trying to affect. And so their argument is that a better solution is what they call regulated dispensation, where you have to place orders like 1 period in advance. So you can't really make decisions in the hot mode. And so then that's going to potentially cut back consumption in the hot mode quite a bit. Okay, so you see, as all of your questions illustrate, there's a lot of interesting stuff here, and it matters very much what the model is. I want to talk about one last model on this issue, which is kind of a hybrid. And I really like this result of O'Donoghue and Rabin, JPUB in 2006, where they study optimal syntaxes in a model with two types of consumers. So it's again like Bernheim and Rangel, but they're not thinking about it as states. They're saying there's some guys who are rational consumers, and then there are other guys who overconsume because of self-control problems. So think of it as like a hybrid of the Becker and Gruber-Koszegi models, right? But their thing is actually just a static model. The key result that they have is that irrationality among a very small fraction of consumers, like let's say 5% of people, smoke too much or eat too many hamburgers or whatever. So Matt Rabin has been arguing that we should have a fat tax. So suppose you even have a small fraction of guys who have this problem of overconsumption, and 90% of the people are rational. So your initial intuition might be, well, if 95% of the people are rational, then probably I should not have these taxes because I'm going to create inefficiency for those guys while only fixing problems for a small number of people. But they show that that intuition is wrong because even irrationality among a few consumers leads to a substantial role for corrective taxation or subsidies. So the easiest way to understand that is just with a simple picture. And it again comes back to second order versus first order costs of deviating from the optimum. So let's take the rational guys first. Okay. So this is, let's say, supply of hamburgers, and this is the demand. And this is the market clearing price. Okay. So these guys, they are demanding the right amount, and we don't want to distort their consumption of hamburgers because they're actually buying the amount that's utility maximizing. So let's now suppose, though, that we implement a small tax on hamburgers. And so what's the welfare cost of that going to be? Well, their quantity is going to fall down to here, which is suboptimal, so it falls to some Q hat. And we know that that generates this deadweight loss triangle, the standard familiar deadweight loss triangle. The size of that triangle is proportional, we know, to t squared, right? In contrast, you take the irrational guys. Okay, their demand curve looks like that, same thing, okay? But they are consuming way too much to begin with. Okay, so let's say this is their true demand curve, and they should be consuming Q star, right? So now their actual demand curve is out here, and they're consuming some Q bar, which is too high, okay? And that leads to a different kind of efficiency cost, which is given by this triangle here, which is the fact that they are consuming beyond the point where they're generating surplus, right? Okay, so now I implement the tax on these guys, and so I implement a small tax, and I shift their quantity down to this point, okay? So that's the delta Q. I shift quantity here. Now the key difference is, because I'm not at the optimum to begin with, the size of the welfare gain from that small tax is a rectangle rather than a triangle. That is, it's proportional to T. So because I'm consuming too many hamburgers to begin with, when I reduce your consumption of hamburgers by 1, that has a first order utility gain for you. And so for these irrational guys here, there's a benefit, like from a 10% tax, the benefit is going to be proportional to 10%. For the rational guys, a 10% tax is going to only generate an efficiency cost of 1%, proportional to T squared. And so as a result, even if 90% of the people in the economy are rational and 10% are irrational, you still want to have the tax on the good because you get first order benefits from correcting the internality and only incur second order deadweight costs. Yeah.
Why these people are being irrational?
So it's possible you wouldn't want to tax at all. Like if the hamburgers are the hot state, you know, you run and get a hamburger in the hot state, then it's the tax is not going to do anything, right? But that's why I say think of it as a hybrid of the Becker and Gruber-Koszegi, not the Bernheim Rangel. So what I'm saying is it's a different point. So in a model where taxes are desirable, you want to have taxes even if most of the guys don't have a problem because of this property of second order versus first order costs. But there's a broader issue of whether taxes are actually the right policy instrument, absolutely. Okay, so the last thing I'm going to talk about on externalities is, in this context of behavioral stuff, is an application to retirement savings, which is by, so I was going to talk about some of this stuff early on in the context of taxation of savings, but I'm going to do it here instead because I think it fits well with these types of papers. So by far, the most important application of this stuff is to retirement savings. Many people believe that people don't save enough for retirement because of various discounting problems or myopia or whatever, right? So there's this general presumption in both the academic and policy debate, which we can debate, you can ask, is it actually clear we should be trying to make people save more? But certainly, let's take it as given, a lot of people want to try to make people save more. Because you see a lot of people showing up in retirement with basically no money, and poverty rates were high before Social Security and so forth. So there's some sensible reasons why you might think this is an issue. All right, so what are the best corrective policies in the vein that we've been talking about to increase savings? So there's some natural things you think about. A price method. We do that a lot in the US. We have subsidies for retirement savings, like 401ks, like IRAs. And these, we spend a lot of money on this. So the flow expenditure in the US federal government exceeds $125 billion or so per year on these types of retirement savings subsidies. So there's quite a bit behind the idea that we are going to get people to save more by subsidizing it. A different method might be our nudges, or kind of trying to shift behavior through taking advantage of their behavioral problems to change the level of savings. So most prominently here, there's a lot of work on defaults and automatic enrollment in pension plans, which we'll talk about in a second. Then there are commitment devices, exactly as you had mentioned, Mitra, on basically trying to get people to plan ahead and commit to making choices that they might not have otherwise made. So there's a very well-known paper by Bernardsey and Thaler called Save More Tomorrow, where the idea is I get you to basically write down a plan saying, I'm going to start saving more next year. And what's the idea in the context of a beta delta model? It's very hard to say, let's have you start saving more right now because you say, oh, I want to buy this and that. But next period, oh yeah, I'm happy to save more then. And we get you to commit to that now, and that gets you on a better path. And they show that experimentally that has some beneficial effects. And then there's another set of papers, quite a big literature, on information provision and financial literacy. So saying that maybe people are not saving enough for retirement because they don't know how important it is to save or how they should be saving. And so there's a lot of work on experiments that basically try to simplify pension plans and provide information. So I'm going to focus on the first two things here because they're most connected to the externalities lecture. But let me just say quickly, I think this seems to work to some extent. Information provision also, we find some evidence that it works. But all of this stuff is just swamped in magnitude by the defaults and automatic enrollment. It's not even close. Okay, so I think by far the defaults and automatic enrollment, which I'm going to show you in a second, is from a policy point of view, a very, very powerful tool. Okay, so let's start with the price subsidies. So there are several papers. I'm going to talk about a paper by Esther Duflo, Emmanuel Saez, and co-authors Jeff Liebman and others, where they conducted a randomized experiment in collaboration with H&R Block that provided matches for IRA contributions. And the main finding of this study is that providing a subsidy significantly increases IRA participation rates. So let's see that. It's a randomized experiment. You can see it just with a simple comparison of means. So let's focus on the blue bars, which are the amount of money that the individual put in, and then the yellow bars are just taking into account including the match that was provided. So there's a mechanical relationship between the blue and the yellow. So in the case for the people who randomly got a 0% match, they put in $22 in their IRA on average. Okay, this is when you're filling out your tax form. The way it works in the US is you can reduce your tax liability for the previous year by making IRA contributions on April 15th, right? So at that point, you can save on taxes, basically. When they give you a 20% match, that goes up to $85. When they give you a 50% match, that goes up to $155. So very clear evidence that the match makes people put more money in IRAs. That is, the price subsidy works in inducing some set of people to change their savings behavior. Now, an interesting side note to that is that an equivalent government program, which they also discuss in the paper, called the Savers Credit, which is targeted towards low-income people and gives them similar matches, has, I shouldn't say no impact, sorry, that's wrong, that should say has a much smaller impact. It does have an impact, but it's much, much smaller. And the way they interpret that is that salience matters quite a bit. When I tell you that I give you this 50% credit right now, you say, okay, well, that sounds great, I'll do it. Do I know about the Savers Credit Program and all of its various eligibility restrictions? Not really. You see much, much smaller effects. Okay, and so that salience theme is something that I'm going to come back to in a little bit. Okay, so that's price subsidies, and I think that's a pretty robust result that you find in many, many contexts. So a very influential paper in this literature is by Bridget Madrian and Shea, where they show that defaults have powerful effects on savings behavior even though they don't change the budget set. Okay, so this paper, the idea is that the price subsidy, it makes sense in a rational model why you might start saving more, right? The idea of the default is, what do I make the default option if you don't do anything? So you come and start working at Harvard. If you don't fill out any of the paperwork, there's some plan that you get defaulted into, like you get 2% of your paycheck deducted and invested in some money market funds or whatever. So what they show is that the default is tremendously influential in determining savings behavior in a way that is clearly inconsistent with the neoclassical model, right? Because it hasn't changed your budget set in any way. So let's look at that evidence. So they look at a company which switched to an automatic enrollment policy in a couple of years and then switched back to the policy they had before where you had to sign up for 401ks if you wanted to. It was totally optional, okay? So they compare three groups. These guys in green are hired before the automatic enrollment was in place. And what's shown on the x-axis is how long you've been at the company and the fraction of people contributing to the 401k plan. So this is going up over time because people figure it out, and as people get older, they start to think about retirement. They start putting money in the 401k. So that's just a secular trend. But look, both before and after automatic enrollment ended, the thing is roughly like this, where something like less than 40% of people are contributing to the 401k in the first year. But in the case where you're automatically enrolled, where you're perfectly well able to undo what the employer does, there's no change in what you're able to do. The fraction who are enrolled exceeds 80%. Okay, so it looks like something 85% of people just go straight into the 401k, even though they could have perfectly well done that before, right? And what's more, if you look at how much they're contributing to the pension, you can see very clearly that the default matters a lot. They defaulted people into a 2% contribution. 2% of your paycheck was contributed to the 401k. And if you just plot a histogram of those contributions for the same three groups, there's a big spike exactly at 2%. So the way to think about this is like, roughly 80% of people, they're like not thinking about this at all. They say, there's some paperwork going on for me that's putting some money in a employer pension account. I'm not going to worry about that, and I just leave that alone. Okay, so the default ends up raising savings in these 401k accounts quite significantly. Now, as I was saying, because this is hard to explain with like even a simple deviation from a rational model, like you might say, well, maybe there's some fixed cost of dealing with this paperwork, and that's why people don't do it. But the fixed cost would have to be implausibly large in a standard model to explain it, because the utility consequences of saving 2% or a few percent more for retirement every single year are enormous over your lifetime. So how can you explain why people don't do this? But, one way you can do it in a paper by David Leibson, Gabriel Carroll, and others in the QJE 2009, they propose a model with optimization costs and hyperbolic discounting, and they argue that that can explain the pattern. So what's the idea? Hyperbolic discounters, they say, look, in every period, there's some cost of dealing with this pension stuff, which I find uninteresting, and I don't want to pay that cost, right? But from a period by period point of view, it's no big deal if I put off this decision by a month, right? I mean, that doesn't have that much of a lifetime cost. And so in every period, the hyperbolic guy says, well, I'll deal with this next period. And so even with a small cost of delay, you can get people not doing anything for a long time in that time inconsistent model. And an interesting implication of that from a policy point of view is if we actually reduce your options and give you a short deadline, where you say you must decide within X number of months, you can actually increase participation. Whereas in the standard model, you would say that's only going to reduce participation because people have less time to figure it out, right? Because you basically kill off this motive of constantly postponing it. So what I want to talk about, the last thing I want to talk about in this context is what these policies are actually doing to savings behavior, which has direct policy relevance. So I'm going to talk about this recent paper we're just working on with John Friedman, Torolds, and others using Danish data. And so let me explain the questions that this study addresses and why it ties into this. So this evidence I've shown you on how defaults and price subsidies increase savings is confined to the retirement accounts themselves. But what you're really trying to do is raise the total amount that people save for retirement. And it's not at all clear from the evidence I just showed you that you succeed in accomplishing that goal. So in particular, defaults could just lead to a shifting of assets from non-retirement to retirement accounts, right? So suppose you've got a person who's totally inattentive and doesn't pay attention to their pension plan. Even that inattentive individual still has to satisfy his true budget constraint, right? Coming back to the behavioral welfare stuff, we talked about how that always binds. And so what I might do if you default me into this plan where I'm saving an extra 2% more is I say, okay, for some reason my pay has fallen. I don't quite know what's going on, but I'm going to consume exactly what I was consuming before. I'm going to buy the same house. I'm going to consume the same amount of food and so forth. So what ends up happening in that model, I just one for one will see my bank balance run down or my credit card bills go up, and I end up being in the same net financial position because I've got an extra 2% in the pension, but 2% less outside the pension, and I haven't thought about anything, right? So just the fact that people are inattentive and are being induced to save more in the retirement account does not in any way tell you that this is a desirable policy. Analogously, with price subsidies, we give you a subsidy to save in the IRA or the 401k, people save more there, but are they actually saving more, or are they just taking money they would have saved anyway and putting it in the 401k so that they get the tax break? So there's an enormous literature on this second question in public finance that goes back to the mid-'80s, studying the IRAs and the 401ks in various ways. And there's a debate, a well-known debate in the literature between Engen, Gale, and Scholz, and Paterba, Venti, Wise, who have different readings of the evidence on whether the IRAs, the $125 billion tax expenditure, is generating new savings or leading to shifting. The reason the US literature is really inconclusive on this is that data in the US on wealth outside retirement accounts is very limited. So think about the type of data you'd need. You'd need information basically from people's banks, from their brokerage accounts and so forth, along with their retirement accounts to figure out if they're shifting assets. And you just don't have that in the US. So we use data from Denmark, where because they had a wealth tax, they have a third-party reporting system. It's like Fidelity and Bank of America, and every bank report directly to the Danish government what everybody's balances are in all of their financial accounts. Okay, so that's the ideal type of data to directly get at this question. And so let me just set this up and we can finish in the next lecture. So we start by studying the price subsidies in the Danish context. You need to know a little bit of institutional background, which is that Denmark has two types of pension accounts, what they call capital pensions and what they call annuity pensions. Capital pensions are paid out as a lump sum when you retire, and annuity pensions are paid out as an annuity. Okay, so there are these two different options. In 1999, Denmark had a reform which lowered the subsidy for saving in capital pensions by 12 cents per kroner. Okay, so they made it less attractive to save in these capital pensions. So what we do is ask two questions. How did that reform affect contributions to the capital pensions? That's like what's been done in the US. How does the match affect contributions to that account? And then we ask how much of the money was shifted to the other type of pension and shifted to non-retirement savings. And so let's just start with this simple result. So 99, the subsidy for the capital pension was reduced for these guys who were in the top income tax bracket, but not for people below the top income tax bracket. So standard diff and diff, super sharp given the amount of data that you have. It's very clear that people start to contribute less to the capital pensions consistent with the prior evidence. So I'll stop here, but what we'll talk about next time is a lot of this money is basically shifted to these other accounts, and it ties back to this model of active versus passive choice that we've been discussing.